All right, we are doing multi-step function inverses. All right, so if you remember, there's a process to the inverse. It kind of has its own stages and steps. So we'll just be following those stages, and then we just use our order of operations or reverse operations to kind of take care of it and make sure it's in a form that we are more able to deal with. And it looks like we have some fifth root exponents kind of going on here. So let's just dive right in. All right, so the first one is, I'll just go ahead and do all the steps. So our first step is you write out the problem. Don't do your work on the original. F of x is x to the fifth over 7. All right, so the first thing you want to do if you have f of x is change it into your y. So that's you can always do that. All right. Then you want to switch the letters. You have to switch the letters. That's kind of the tricky step for inverses. So that now becomes x equals y to the fifth over 7. So all I did is I interchanged x and y. So that's all that happened here. And then for the inverse, and this is just like if you're reflecting over the y equals x line. So remember, that's what an inverse is. It's the reflection over the y equals x line, or you switch x and y. And then now we solve for y. We want to get y by itself. So we got to go ahead and use reverse order of operations. So one of the tricks that I kind of say is, Pemdas, please excuse my dear Aunt Sally. Now, this is your order of operations. This is how you would normally do it, but for reversing it, we were going the other way. But there's a couple different ways you can think about it. That's just kind of the math way of doing it. So to get y by itself, I move everything that's not connected to the y to the other side. It's the multiply would come next right here. So I get rid of that multiply. What you do to one side, so divide by 7 is a multiply by 7. You do to the other side, multiply by 7. So I now have 7x equals y to the fifth. To get y by itself, what's the opposite of an exponent of 5? The fifth root. Fifth root has a couple different ways it can be expressed. It could be fractional exponents, but in this case, I can see that they have radicals. So we'll just do that. So we do the fifth root. So a fifth root means that 5 is in this little crux or this little corner. That's what makes it a fifth root. Do that to both sides, and these undo themselves. You don't have to worry about the plus and minus here. Usually you would, but in this case, it's an odd exponent, so it could be plus, it could be minus. It won't be both. You got one answer for these. So your final answer, these undo themselves, and you get y equals the fifth root of 7x. And let's see if they have anything that's a little bit different. And then they just want that final notation. Let's not forget to put it in inverse notation. So I changed it from f of x to y. So now this is f inverse, f to the negative 1. That's f inverse. Our variable is x. And we have fifth root of 7x, which looks like this one right here. Let me just double check. Yep. Okay, and let's see, they go through the exact same process. Cool. All right, let's see if the next one's any different. All right, same type of problem, level 1. Everything looks exactly the same type of problem, same type of format. So follow those exact same steps. Yeah, let's go ahead and I'll do one more for these. So our f of x, change it to y. So I'll just go ahead and, at least that's not too bad of a step to skip, rewriting the problem in this case. All right, yeah, it's good I'm doing this. I didn't even realize it. There's our 1/5 power. Just as a note, x to the 1/5 The bottom of your exponent when it's a fraction means it's a radical. So this is the same thing. These two things are equal right here. Okay, a 1/5 power is the same thing as a radical 5. The fifth root, not radical 5, the fifth root. All right, so that's what we got kind of going on here. To undo that, which is coming, we would just do the exponent of 5. The fifth root, or a 1/5 power, notice that an exponent of 5 would undo both of those. All right, so then just going through the process, our next step is to switch letters. Then undo everything that keeps y from being by itself. So remember, reverse operations, you're trying to unfold everything to get y by itself, so you can't subtract 8. It's trapped by that 1/5. So to get rid of that 1/5, that's the 1/5 power is the same thing as radical 5. So I put everything to the 5th power. All right. So you can rewrite it as radical 5 if you're a little bit more comfortable with that, but just at algebra 2 level, just kind of be ready, and even some more advanced algebra 1 levels, be ready. It undoes it. So an exponent to an exponent means multiply. That undoes it. And what you do to one side, you do to the other. Last step, subtract 8. I mean, besides the rewriting it in that inverse notation form. So I got x to the 5th minus 8 equals y, and they like that y to be rewritten as f to the -1 of x. Function notation is what they like. So x to the 5th minus 8. X to the 5th minus 8. Looks like that one right there for this problem.